Okay, today we're reviewing for the stretching and shrinking graphing test. It's not all graphing, but a lot of graphing. And some of the things you got to know include in what order do you do a problem like you see on the board in red here. So I'll pause for a second while you number them 1, 2, 3, and 4. What order do you think? All right, number 1, he says reflect. Now I want some of you, F-L-E-C-T, some of you are going to probably have done it in a different order that's also right. But reflecting first is okay. Reflect over, and it's, let's see, this negative here is up, down, because it's on the outside, you know, vertical on the outside. So it's a vertical reflection would have been a good answer. Or you could say a reflection over the x is correct. Good. Number 2 then. If you do reflect first, what would you have to do next? All right. And that means vertical stretch factor 3. I would appreciate if you'd throw the word factor in for your answers. All right. Mr. T, finish it. Does the order of the last 2 matter? Yeah, I've told you what to do in first, and generally, what's the rule? Inside and first, and then outside. Good. So then, left 2 and up 5. Raise your hand if you had an answer like that. Okay, good. Is there another way? Yes, sir. Yes. In fact, I've told you that stretching before you flip is a good idea in gymnastics, and it's also a good idea in your math problems. Why? Because it's easier when you're starting with a parent function to do the stretch first, because the stretch is the hardest thing. Do that first because you're using the parent function, which is the easiest function you'll have, and then you do that hardest thing, and then you can flip. It's really not hard to flip at something, so do that next. Okay, so it's really best to start with the stretch and then do the flip. But here's the main theme. All of these are multiplies. They need to be done before the add subtracts. Okay? Give you another one that's kind of like that and tell me what you think on this one. All right, it's going to have y equals negative, absolute value of negative 2x minus 3 plus 5. There's 1, 2, 3, 4, 5 things this time. So order them 1, 2, 3, 4, and 5. Now wait, you know what? I'm going to put this plus 5. Here's the problem. I think some people are going to start thinking that you just do them in the order you see them, and that's not right. I'm going to put this 5 in front. And that is not 5 times. That's 5 plus. You should not assume that you do them in the order from left to right. That is not correct. I'm going to pause for a second when you do that. All right, he's doing both reflections first. But do you remember that I was suggesting that you stretch before you flip? But it's not required. So as long as it's a multiply, that's a multiply, that's a multiply, and that's a multiply, those have to be first, and it really doesn't matter what order. But I recommend, if you're actually doing it, you stretch first. But reflect over x, reflect over y, and again, it does not matter what order, if the y is first before the x or whatever. And then stretch, that's I think what you said, and you are correct. Factor 2. Oh, okay. Shrink. Yeah, you're right. You just said the 2 reflections. So I'll let you say it then. Go ahead. Horizontal shrink, factor 1/2. Very nicely done. All right, those 3 in whatever order have to be first. Okay. Coda, 4 and 5. Right 3, up 5. You are correct. All right. Now let me make it even harder. What if I took that plus out of there? Now is that 5 a multiply? Or is that 5 still a positive 5. That's like moving the thing up 5. It's still up. Yep. Because this is a minus sign. And unless I would say times, which would be really weird because the negative would have to be in front of the 5 usually. Unless I'd say times, that would mean 5 minus. All right. Okay, let's go on. We've done a couple of the order problems. Now, what if I actually give you a graph that has been stretched and shrunk and all that? Okay, here's one. Please tell me the equation for that. Write it down on your iPad. Be prepared to turn it my way in a second here so I can see if you know how to do this. By the way, side note, the homework that's due today, that same homework, you just have to finish it. That's what your assignment is for tonight. And since it's 2 days assignments rolled into one, I'm probably grading it tomorrow right before we take the test. So make sure you do it. Some people get the confused notion that, oh, I thought I was just supposed to study for the test. Well, yeah, and then not do all your homework? That's really stupid. Your homework is the studying for the test. And then whatever you do on top of that homework, that's the actual studying part. You're really just doing your homework, which is important. All right, do you get that this has been stretched? How do you know it's been stretched? You should look for this spot right here. The vertex, the starting spot of the function. There's an important spot for all the functions, okay? And then I should go over 1 and up 1, and if there isn't a dot there, then the thing must be stretched. Okay, then you just got to figure out where it moved to. Well, this one went up twice as high as it used to be. Don't think plus 1, because this one didn't move only up 1. Just get twice as high as it used to be. There should be a spot at over 4 and up 2. And instead, there's a spot at over 4 and up 4. Obviously, looking to me like it's doubled. All right, so that is an important spot to look for. So y equals, how many of you remember to y equals or an f of x equals? Okay, good. Yes, sir? I don't think you want a parenthesis, though. Isn't this a square root function? Okay, square root, and then what? Everything else was fine. Keep going. X minus 2 plus 2. And now let's see if you've got all the pieces. Has this thing been flipped compared to the parent? So there's no negatives needed. It has been moved right 2. Can't argue with that. It has been moved up 2. All right, last thought. There's a way for you to know if you're right. You just need to check it with an XY chart. I can be positive that I haven't screwed something up. Now, I think that 2 went in as an X and gave me 2 as a Y. But you don't just write 2, 2 on the graph. You go 2 here, and then you check it. You stick the 2 in here, and let's see what happens. 2 minus 2 is 0. Square root of 0 is 0. 2 times 0 is 0. Plus 2 is 2. 2 comma 2 is on there. That's a good sign, but I would check one more point. So I'm going to try sticking in a 3 and see if I really get the right thing. Stick in a 3. 3 minus 2 is 1. Square root of 1 is 1. 1 times 2 is 2. 2 plus 2 is 4. Now, if this had been wrong, I wouldn't instantly erase my graph. Maybe I screwed up in putting the numbers into my equation. But 3 comma 4, over 3 up 4, it is on my graph. I'm happy because both spots matched up. I probably did it right. Do you get how that would save you from a lot of mistakes? I hope you get that. All right, next I'm going to actually have you graph one. This is kind of the meat of the test, the main thing. It's interesting how I say that. Meat should probably be a smaller part of our diet than the main thing. But anyway, the meat of this is I give you an equation and you graph it. And this has no stretch, so I'm going to put a 2 in front. Because this test is about stretching and shrinking, so we're pretty much going to stretch and shrink on every one. Now, if you're struggling with the parent function thing, like, okay, I got to graph this, I got to flip it, I got to move it, I got to make an XY chart. You don't have to do anything except an XY chart. Like, you do an XY chart, you can skip the rest of it if you want to. Smart to use one way to check your answer. All right, I'm going to pause for a second. Yeah, you did. All right, let's check and see if you're on the right track here. I'm going to make an XY chart just to make a point that I don't even have to graph the parent function and move it and stretch it and all that stuff, because it's so likely that you'll in the middle make some dumb mistake like, oh, I'm going to move it down 4, and that's not down 4. And you'll never even know you made a mistake. But I'm going to stick in 4 because that's a logical one, because it'll crash part of my function. That makes 0, and everything times 0 is all 0, plus 5 is 5. 4 comma 5 better be on your graph. Check it. Is it? Yes, ma'am. Is it a question or a... Okay, I don't think it was a question. All right, then I'm going to try another point. I'm going to stick in a 5. Okay, so if I put a 5 in here, 5 minus 4 is 1. 1 times negative 2, see, negative 2 times the 1 would make negative 2. Negative 2 plus 5 is 3. 5 comma 3, better be on your graph. 5 comma 3. 1, 2, 3. All right. Now, if I didn't know what shape this was, I could be in trouble, though, with this method. Because if I thought that this was like a parabola, I might go, okay, so my graph looks like this. You get what I mean? So you got to know, okay, what shape is that? By the way, what is it? A V shape. So it should be a V shape. And I've got 2 dots on it, but I still don't know where the V is. All right. I'm going to go another dot. I'm going to try a 3 in here. If I put in a 3, I'm going to get some of this junk out of here. Okay. If I put in a 3 minus 4 is 1. Absolute value of 1 is 1. Negative 2 times 1 is negative 2. Plus 5 is 3. I got a 3 again. Could that be right? Yes. You're looking for that kind of a mirror point where this and this kind of match up, because if it's going to be a V, you know, I need something like that. So, hey, it looks like it's working. Raise your hand if you had that one right. Okay, good. Notice, I didn't even have to remember to flip it or to stretch it or any of that stuff. What's up? What's happening?
My notability just crashed out all my notes. Luckily, I am back to Google Drive.
There you go. You're living proof that we want to have that sucker backed up to Google, because that really stinks. His notability just wiped everything. So, all right. Good thing you're backed up. All right. Let's get to I graph something, and that's like not a normal shape, and then you tell me how I stretched it by writing an equation for it. So again, this is not a normal parent shape, you know. It's going to be like a baseball cap. Okay, there it is. And now I'm going to make a copy of it, clone it, grab this one, change the properties on it to be purple. All right, and now all I've done is move it. Now I'm going to actually move it here. Actually, I won't be able to see it. Then I'll move it here. And then I'm actually going to also, I'm just going to start with that, because I know a lot of you are going to make a mistake as it is, even without throwing a stretch in it. So tell me what that new equation is for the purple one. Remember, it's relative to the red one. It's not a parent thing that you got to move from the origin over here. Okay, it's compared to the red one. What's the equation for the purple one? Pogozelski, tell me what to do. Okay, so how do you write the equation for that then? Very nice. How many of you forgot the F? Be honest. The most common mistake last test. If you don't know what the function is, put the F in there. Okay, now let's see what would happen if I also added a stretch or a shrink. I'm going to take dots here. These are the dots that kind of comprise my baseball cap. Do you get, if I make this thing right now has a width of 4. So if I go over here and make it have a width of 2, I have made it half as wide. This width right here is a width of 6. So if I go half of that and move it down 1, I'm going to have a width of, instead of 6, a width of 3. And then I'm going to move it down 1. There we go. Nope, it's got to be the same as level as the other one. There we go. Okay. Do you get how my baseball cap, the bill is half as long as it used to be? Another way you can tell what's going on here. Okay, now this point right here to that point right there, that has a width of 7. So now I got to go 3.5 and 1 higher than the other one. So 1, 2, 3.5. So that's going to be right here. I'm going to erase this line right in there so I can see that better. And this right here, this point right here, that has a width of 8. So I'm going to go over 4. Here's my new baseball cap. Now I even did that with you, and it's still going to get some people get it wrong. Write me the equation kind of like this for that little black baseball cap. It's easy. What do you think? And then a minus what? All right. You're close. You're very close. Let's analyze this a little bit. Would you agree that by putting a 2 on the inside, she's saying that it's half as wide as it used to be? Do you agree with her on that? Good. You're right about that. What's that? On the end, you want to change that to a -1? Maybe that'll be enough to do it, okay? Now, would you agree that by doing this, she's saying that we moved everything to the right 1? Is that what she's saying? Is that what actually happened? No. It just moved to the right because it shrunk. I know that's confusing. But this thing did not get shifted to the right. It's just it used to be this wide, and now it's this wide. Okay? And it did get moved down 1. So I'm going to say just an X in here. Don't really even need that parentheses. And then -1. That is the right answer. How many of you had that? Only a few of you. All right. Now, how could I be sure I'm right? What's that thing that kind of helps you? An XY chart. Let's see if we can use an XY chart for this. All right. So we take the original parent point, which was like 8, or -8, 3. And if I do this to it, what should that 2 do? Should it mess with the X or should it mess with the Y? It should mess with the X. The X is the -8. Should we actually multiply it by 2? No, it's counterintuitive, so you could either multiply it by 1/2 or divide it by 2. So this 8 becomes -4. Do you get what just happened there? The -8 turned into a -4 because we applied the shrink of 2 to it. All right, how about the Y? Of this function I just did, what does the Y value do? Some of you aren't listening. I'm going to ask it again. What's the y value doing on this function right here? Compared to the original, it's what? Going down 1. Can you trust this on the outside? Yeah, so it is down 1. So the 3 changes into down 1. A what? A 2. So is negative 4 comma 2 on my graph? There it is, negative 4 comma 2. It's on the graph. You get how that worked? I checked myself. I thought this was the right answer. So I checked it by doing this to the x, which was not timesing it by 2, but cutting it in half, and doing that to the y, which was moving it down 1, and we can trust it. So we just took our y value of 3 and moved it down to a 2. And we took our 8, negative 8 here, and we cut it down to a negative 4 there. And negative 4 comma 2 was on the graph. It was right there. Okay, so I can double check to make sure I didn't screw that up. I know it seems like it moved right, but it's because you compare the original width, which used to be a width of 8, and now it can only have a width of 4. See what I mean? And it's when it's shrunk, it's not shrunk this way and this way. That's the biggest mistake I think people make on these in their head, is they think when I shrink a function, that means it shrinks towards the middle like this. No, it shrinks towards this axis. So when I shrink it, it has to be shrunk down that way. All right. Your homework is to finish that assignment I gave you the other day. I'd check it with the answers posted. Have a great day.